Dear students, welcome. This is our 10th class on statics. Today, I shall try to solve these three problems. Problem number 6, 7 and 8. Today's problem number 1. See, today's problem number 1. ABC is a triangle. You are given that ABC is a triangle. Forces PQR act along the lines GA, GB, GC respectively and are in equilibrium. Prove that if G is the centroid of the triangle, then P is to Q is to R equal to GA is to GB is to GC. Now you see, ABC is a triangle. ABC is a triangle. G is the centroid. ABC is a triangle. G is the centroid. Suppose D, E, F are the midpoints of BC, CA and AB respectively. D, E, F are the midpoints of BC, CA and AB respectively. Now join AB, BE and CE, CF. CF will definitely pass through this point, and this point is G, the center of gravity, the centroid of the triangle. The forces PQR are acting along GA, GB, GC, P, Q, and R. PQR are acting along GA, GB, and GC respectively, and are in equilibrium. It is given that the three forces are in equilibrium. Three forces PQ are in equilibrium. Let DEF are the midpoints or middle points of the sides BC, CA and AB of the triangle ABC, of the triangle ABC, BC, CA and AB respectively. You may write this word respectively. Of the triangle ABC. Let AD, BE and CF meet at the point. Meet at the point G, which is obviously the centroid of the triangle. Which is the centroid of the triangle? Is the centroid of the triangle. Of the triangle ABC. Which is the centroid of the triangle ABC. Now, the forces acting along, now the forces PQR acting along GA, GB and GC and GC are in equilibrium. Acting along GA, GB and GC are in equilibrium. Therefore, by Ramen theorem we get. Apply Ramen theorem. Therefore, by Ramen theorem we get. Therefore, by Ramen theorem we get the magnitude of each force is proportional to the sine of the angle between the other two. P, sine of BGC, sine of the angle between the other two, sine of BGC. This is equal to magnitude of the force Q should be equal to sine of the angle CGA. This is equal to R by sine AOB. Sine AOB. AOB. By Leibniz theorem, we get this. Suppose this is number 1. I mark it as number 1. By geometry, you know that the area of the triangle BGC equal to area of the triangle CGA and the area of the triangle AGB. By geometry, we get by geometry we get area of the triangle BGC. This is equal to area of the triangle CGA equal to area of the triangle AGB. By geometry we get this one. Suppose this is number 1. We get this one. Now area of the triangle BGC equal to BGC. Consider this triangle BGC. Area of a triangle is equal to half into product of any two sides. GB and you may write GB. Product of any two sides into sine of the included angle. Sine of the included angle. In the last class also I explained this. Suppose in a triangle ABC. Suppose in a triangle ABC. This is a triangle ABC. The sides BC will be denoted by A, it will be denoted by B, and it will be denoted by C. Suppose AD is the perpendicular. Suppose it is a perpendicular of the AD is perpendicular on BC. What is the area of the triangle? We know that the area of the triangle half base into altitude. Half base into altitude. This is equal to half. BC is denoted by A. What is AD? AD equal to AC sin B, sin C, AC sin C, AC sin C. This is equal to half. What is AC? AB sin C. Area of the triangle. Similarly, if you consider this triangle, AD can be written as AB sin B. What is ABC? Or you can write half of AC sin B. Therefore, area of this triangle equal to half of AB sin C or BC sin A or AC sin B. Means product of any two sides, half into product of any two sides into sine of the included angle. Sine of the included angle. Half into product of any two sides, sine of the included angle. This means sine BGC. This angle will be equal to 2 times of the area of the triangle BGC divided by GB into GC. You may write like this. Or you can write 2 times of area of the triangle BGC. 2 times of area of the triangle BGC divided by GA GB GC. This multiplied by GA. We have multiplied GA by GA in the numerator as well as in we have multiplied GA in the numerator and in the denominator also. This term, suppose this term is K into GA. Sin BGC equal to K into GA. Again, area of the triangle CGA. Perhaps you have understood this one. Sin BGC can be replaced by K into GB, where K equal to this. Where you may write where K equal to. K equal to 2 times of integral B, 2 times of the area of the triangle BGC divided by GA, GB and GC. Product of this. Obviously, since the area of the triangle BGC equal to area of the triangle CGA equal to area of the triangle AGB, therefore the area 2 times of the area CGA will also CGA divided by GA GBGC can also be replaced by K, and the area of the triangle AGB by GA should be replaced by K. Now, consider the triangle CGA. Perhaps you have understood this one. Sin BGC can be replaced by K into GA. K, GA. We have replaced BGC by CGA simply. Means we have used number 2. We have used number 2. By 2, you may write here by 2. We have used 2. Other terms are as usual. Other terms have been written as usual. 2 by GA, GBGC. Only BGC has been replaced by CGA, and also BGC has been replaced by AGB by 2. You may write like this. Now, the area of the triangle CGA equal to half into CGA, product of any two sides, GCGA into sine of the included angle CGA. This means sine of the included angle CGA should be equal to CGA, the area of the triangle CGA by GCGA or 2 times of area CGA GAGBGC into GB. This can be written as K into GB. Similarly, triangle AGB. Similarly, area of the triangle AGB equal to half into product of any two sides into sine of the included angle AGB, sine of AGB, Therefore, sine of AGB should be equal to 2 times of area AGB, area of the triangle AGB, divided by GAGBGC, and we have written GC in the denominator, therefore write in the numerator also. Therefore, this is equal to, you can write K into GC. K into GC. I am very sure this is not AUB, it is AGB 1. AGB. Thus, sin BGC can be replaced by K into GA. Sin CGA can be replaced by K into GB. Sin AGB can be replaced by K into GC. Therefore, from 1 we get. Therefore, 1 implies. 1 implies means from 1 we get P by K into GA equal to Q by K into GB equal to R by K into GC. This means that P by GA equal to Q by GB equal to R by GC. This means that this implies that P is to Q is to R should be equal to GA is to GB is to GC should be equal to this. GA is to GB is to GC. Perhaps you have understood this one. It is very easy. Just simple geometrical relations have been used. And we have applied Rame's theory. Today's question number 1 has been proved. Now, what is the question number 2? And as a whole, the question number 7. S is the orthocenter of the triangle ABC. S is the orthocenter of the triangle ABC. Forces PQ are acting along HA, HB, HC are in equilibrium. Prove that PQ are P is to Q is to R equal to A is to B is to C. What is this? Suppose this is ABC is a triangle. In the triangle, we draw perpendiculars. Now we draw perpendiculars. It will be like this. AD, BE and CF are perpendiculars. ABC is a triangle. AD, BE, CF are perpendiculars on BC, CA and AB. And they meet at the point H. H is the orthocenter of the triangle. ABC is a triangle. You may write ABC is a triangle. We draw perpendiculars. AD, BE and CF on BCCA. BCCA and AB respectively. We draw perpendiculars. AD, BE and CF CF on BCCA and AB respectively. Let they meet up. Let AD, BE and CF meet up at H. Therefore, by definition, H is the orthocenter of the triangle. H is the orthocenter of the triangle ABC. H is the orthocenter of the triangle ABC. Now, since the forces PQR acting along HAHB, HAHB and HCHB, HC respectively, and are in equilibrium. Therefore, by Lami's theorem, we get this is the force P. H, S, P, Q, and R. We get P divided by sine BHC, sine the angle BHC, sine BHC. This is equal to Q by sine CHA equal to R by sine AHB. Since three forces acting at a point are in equilibrium, then by Lami's theorem, the magnitude of each force is proportional to the sine of the angle between the other two. The P force should be proportional to the sine of BHC, sine of the angle BHC. Q is proportional to C, sine of CHA. Thus, we have applied the Lami's theory. We have applied Lami's theory. Now, see the diagram here. Two lines, these two lines are cutting like this. Then this angle will be equal to this angle. These two angles are called the vertically opposite angles. This angle equal to this angle, and this angle will be equal to this angle. This angle is equal to this angle. Now, this means that P divided by sine. Here you see BHC, BE and CF. Now consider the line BE and CF. Consider these two lines, BE and CF. Consider these two lines, BE and CF. This angle should be equal to EOF. BHC, this angle should be equal to EHF. Angle EHF. This is equal to Q divided by sine. CHA, CF, CHA. Now, right. CHA, AD. This is AD. And CF, these two lines. CHA, this angle should be equal to this angle. What is this angle? CHA equal to AHB. AHB. This angle. What is this angle? Equal to this angle. And here CHA, this angle should be equal to FHD, this angle should be equal to FHD, this angle. FHD. This is equal to R divided by sine of the angle AHB. This is suppose this is AD, AHB, and BE, right? BE, this BE. This is BE. AHB, this angle should be equal to this angle. Means DHE. This angle should be equal to R divided by AHB. This angle should be equal to this line and this line. We shall definitely get this angle, DOE, DHE, sine of DHE. Because the vertical angles are equal. Two lines cuts, these two angles are equal. Only Now, you see the diagram here. Just see the diagram. These are it is EHF. EHF, this angle. We have to find this angle. Now, this angle is 90 degree. You see, this angle is 90 degree. What is this angle? This angle is also 90 degree. What will be this angle? Will be equal to 180 degree minus 8. 180 degree minus P divided by sine 180 degree minus 8. Because this is 90 degree, this is 90 degree. This is equal to Q divided by sine FHD. FHD, because this angle and this angle, this angle will be equal to 90 degree, this angle will be equal to 90 degree. This is a quadrilateral. This plus this should be equal to 180 degree. What is this? 180 degree minus B. 180 degree minus B. And here also sine DHE. DHE should be equal to this angle is 90 degree. You see, this is 90 degree because it is perpendicular. This is 90 degree. This angle is also 90 degree. Consequently, what is this? Equal to 180 degree minus C, because it is a quadrilateral. CEHD. CEHD is a quadrilateral. Therefore, sum of the interior angles will be equal to 360 degree. The sum of this angle and this angle are 180 degree, 90 degree plus 90 degree. Therefore, sum of this and this should be equal to 180 degree. Sin 180 degree minus C. 180 degree minus C. Sin 180 degree minus C. Now, this means P by sin A equal to Q by sin B equal to R by sin C. R by sin C. This means P by A by twice R equal to Q by B by twice R equal to R by C by twice R. Since A by sin A equal to, in a triangle, in any triangle ABC, you will get A by sin B, B by sin C, C by sin C equal to twice R. Sin A should be equal to A by twice R. Twice R will be cancelled. Therefore, you will get P by A equal to Q by B equal to R by C. This means P is to Q is to R. This is equal to A is to B is to C. Or you may write P is to Q is to R. Should be equal to what is A? BC is to CA is to AB. BC is to CA is to AB. Perhaps you have understood this also. It is the simple application of Lami's theory. Now, question number 8. Today's question number 8. Forces acting at a point are represented by AB twice BC twice CD, DA and DB, where ABCD is a square. Where ABCD is a square. It has been called. Thus, you have understood the diagram. A simple problem. What is question number 8? ABCD is a square. Suppose this is A, B, C and D is a square. AB twice BC twice CD, DA and DB also. DB. ABCD is a square. To prove that, so that they are in equilibrium, this means that sum of these forces should be equal to 0. We have AB plus twice BC plus twice CD plus DA plus DA plus DB. This can be written as AB plus BC plus CD plus DA. Right, plus DA. AB plus BC plus CD plus DA. Here you will have to write BC plus CD plus DB. Now, law of polygonal forces. What is law of polygonal forces? If a number of forces acting at a point be represented in magnitude and direction by the sides of a closed polygon taken in order, then the forces will be in equilibrium. Now, you see, AB, BC, CD, DA, AB, BC, CD, DA. These forces acting at a point, the forces acting at a point are represented by AB, BC, CD and DA of a closed polygon. Here it is a closed square taken in order. Therefore, by the polygon of forces, the combined effect of this will be equal to 0. What will be this? Polygon of forces. Forces will be equal to 0. And by the law of triangle of forces, if three forces acting at a point be such that they can be represented in magnitude and direction by three sides of a triangle taken in order, then the forces are in equilibrium. You see, BC, CD and DB, it is a triangle. By the law of triangle of forces, it is a triangle. Triangle of forces. Therefore, this should be equal to 0. By the law of triangle of this, the three forces acting at a point represented by three sides of a triangle taken in order. By the law of triangle of forces, they are in equilibrium. Also, these four forces acting at a point are represented by the sides of a square, sides of a polygon taken in order. By the law of polygonal forces, the forces will be in equilibrium. Therefore, the forces are in equilibrium, so that they are in equilibrium. Therefore, the forces are in equilibrium. The forces are in equilibrium. Are in equilibrium. Dear students, today I will have to stop here. Thanks for attending the class. Thank you very much. In the next class, we shall try to solve some more interesting problems. Thank you.